Low water may halt Hoover Dam's power. The shutdown of one of the largest electrical power plants in the Southwest will begin with air bubbles on a turbine inside the Hoover Dam. The bubbles form when low water levels in Lake Mead, the reservoir behind the dam, create pressure differentials in the water flowing into the generators. As they move from areas of low pressure to high, the bubbles collapse and explode, scouring the turbine blades. The generating unit will then start to buck and vibrate, the blades will become pocked and pitted, and the whole thing will eventually need to be shuttered, eliminating the power source that supplies 29 million people in the Southwest with a portion of their electricity. For the last 8 weeks, Choke Point, U.S. has explored vivid examples of the collision between rising energy demand and diminishing reserves of fresh water. What clearly appears to be an unavoidable day of reckoning at Hoover Dam is, arguably, the most striking example in the country of the confrontation between the two resources. A prolonged dry spell, lasting over a decade, is steadily draining the water sources that power Hoover Dam's giant turbines and has left Lake Mead at only 41% full. The lake has dropped 130 feet since 1999 and is now at 1,084 feet, depths not seen since 1956. The Bureau of Reclamation projects it will shrink another 2 feet by next month, reaching its lowest elevation since the reservoir was filled in the 1930s. Power generation has declined in tandem. The falling water levels have prompted federal managers to reduce the Hoover Dam's hydroelectric generating capacity by 23%. If drought conditions continue in the Colorado River Basin, if climate change brings the hydrologic strictures predicted, and if water allocations to the basin states aren't reduced in line with anticipated lower flows, what was once, and for some, still is, unthinkable might happen. There won't be enough water to power the dam's generators, thus shutting down the plant and creating energy uncertainty for millions of people in the region. It is an outcome that would destabilize energy markets in the Southwest, send retail customers that serve millions of residents to the spot market to buy power at up to 5 times the cost and dissolve the illusion that rivers are infinitely malleable to our own purposes. A dam's electrical output is partly a function of the height of its reservoir. More water equals more pressure, which equals more energy. The total capacity at Hoover is now 1,617 megawatts. A 20% decrease from its designed capacity of 2,080 megawatts. Every foot of elevation loss reduces the power potential by 5.7 megawatts. Experts don't know what will happen if the water drops below 1,050 feet, which represents the bottom of the efficiency curve for the current turbines, where more water is needed to produce an equivalent amount of electricity. Such low depths increase the rough zones for the turbines, the generating range in which vibration and cavitation threaten to damage the unit. At extremely low lake levels, like the ones Mead is fast approaching, those rough zones, which usually occur in a narrow production band at medium capacity, could expand to fill the entire generating range, making the turbines vulnerable at any speed. But this unprecedented scenario would be a mystery even to the staff of the Bureau of Reclamation, which operates the dam.